What if I told you that for 2 straight years, gravity over a massive stretch of the Atlantic Ocean just stopped behaving normally? Not a little wobble, not instrument noise. A gravitational anomaly spanning 4,350 miles, wider than the continental United States, showed up in satellite data, peaked in January 2007, and then faded away like it never happened. Scientists spent years trying to figure out what caused it. And the answer? It came from nearly 1,900 miles beneath your feet, where a single mineral, the most common one on the entire planet, quietly rearranged its atoms under pressures so extreme they don't exist anywhere else in the known solar system. That shift was enough to warp Earth's gravity field from space. Let me walk you through how we even noticed this. Back in 2002, NASA and the German Aerospace Center launched a mission called GRACE, the Gravity Recovery and Climate Experiment. 2 identical satellites, flying about 137 miles apart in orbit, chase each other around the Earth 15 times a day. Here's the clever part. They constantly measured the distance between each other using microwaves, down to 1 micron, roughly the width of a single blood cell. When the lead satellite flew over a region with higher mass, it would speed up slightly, stretching the gap. When it passed a lower mass area, it slowed down. By tracking those tiny shifts in spacing, scientists could map Earth's gravity field month by month. GRACE was built mainly to watch water, ice sheets melting, groundwater shifting, oceans rising. But a team led by geophysicist Charlotte Gain-Garanton at Paris City University realized the satellites might have picked up something far deeper. So they dug into the data, and buried in the noise of oceans and ice and weather, they found a signal that didn't match anything on the surface. Between 2006 and 2008, a dipole pattern appeared over the eastern Atlantic, a zone of unusually strong gravity sitting right next to a zone of unusually weak gravity. This wasn't mass being added or removed. This was mass being moved around, deep underground. The pattern peaked around January 2007, and here's what made it even stranger. It lined up almost perfectly with a sudden jerk in Earth's magnetic field that other satellites had recorded in the same region at the same time. That kind of coincidence doesn't just happen. So what was going on down there? About 1,864 miles below the surface sits the core mantle boundary, the contact zone between Earth's solid rocky mantle and its churning liquid iron outer core. Temperatures there rival the surface of the sun. Pressures reach over 1,000,000 times atmospheric pressure at sea level. And the dominant mineral in that deep mantle is something called bridgmanite. Bridgmanite is technically the most abundant mineral on Earth, making up a huge portion of the lower mantle. But here's the thing, we've rarely held it in our hands. It only exists under those crushing deep Earth pressures. The only natural sample scientists have ever studied at the surface came from inside a meteorite. Under the right conditions of heat and pressure, bridgmanite undergoes what's called a phase transition. Its atoms rearrange from one crystal structure, called perovskite, into a denser configuration called post-perovskite. The mineral doesn't melt. It doesn't break. Its atoms just snap into a new arrangement. And when that happens across a large enough region, it changes the density of the rock. And a change in density means a change in mass distribution. And a change in mass distribution means a change in gravity. Garanton's team, who published their findings in the journal Geophysical Research Letters in 2025, proposed that this is exactly what happened. A broad region of bridgmanite near the core mantle boundary crossed the stability threshold and shifted into post-perovskite over just a couple of years. That density change was enough to reshape the gravity field above it, and potentially deform the boundary between the mantle and core by small but measurable amounts. This is still a hypothesis. It needs more data to confirm, and the team has acknowledged that. But think about what it means if they're right. It means our planet isn't just passively sitting there. Nearly 2,000 miles below us, minerals are actively transforming, shifting mass around on timescales of just a few years, fast enough for satellites to catch in real time. We talk a lot about exploring the cosmos, but we've barely scratched the surface of our own planet, literally. If this kind of discovery fascinates you, drop a like and subscribe so you don't miss the next one. And let me know in the comments, what blows your mind more? What's out in deep space, or what's hiding deep beneath your feet?